Good day everyone. Our group will talk about standard heat of reaction and formation. This is our group. Now, let's take a look at the history of thermochemistry. The study of thermochemistry began in the 1780s with the two scientists Antoine Lavoisier and the Pierre Simon Laplace. They discovered that the heat produced in the chemical reaction is equal to the heat absorbed in a reverse reaction. They also explored important concepts such as specific heat and latent heat, which describe how substances store and transfer energy. Using the world's first ice calorimeter, they measure the heat change that occur during chemical reactions. This experiment helped establish calorimetry as a scientific method for studying heat in chemistry. Later, in 1840, Germain Henri Hess expanded the field of the thermochemistry by formulating what we now call Hess law. Next, let's learn more about Germain Henri Hess. He was a Swiss-Russian chemist born on 7 August 1802 and he passed away on 13 November 1815. Hess was both a chemist and a doctor, and he is recognized as one of the founders of thermochemistry. Because of his important contributions, he is sometimes called the father of the thermochemistry. Before the concept of the enthalpy was even developed, Hess made early study on the oxidation and reduction reactions, helping scientists understand energy change in the chemical processes.
Now let's move on to Hess law, introduced by Germain Henri Hess in 1840. He stated that the total enthalpy change of reaction is the same no matter how many steps it takes. In other words, whether a reaction happens in one step or through several intermediate, the overall energy change remains constant. So if we already know two enthalpy values in a series of reactions, we can easily calculate the third in order making Hess law a key principle in thermochemistry. Let's start with the definitions and equation of enthalpy. The standard heat of reaction is the enthalpy change that occurs when 1 mole of matter reacts under standard conditions of temperature and pressure. It is calculated using this equation. Delta H reaction equals the sum of enthalpies of formation of products minus those reactants. On the other hand, the standard heat of formation is the heat change when 1 mole of a compound is formed from its element in their most stable states, also under standard conditions. So basically, both concepts help us understand how energy flows during chemical reactions.
Now, this is formation of water in 3D model.
Let's look at how the standard heat of reaction and formation concept are applied in a real-life application. Let's start with the first one, fuel and energy production. When fuels like natural gas, petrol, or coal are burned, they undergo combustion reaction. These reactions are exothermic, meaning they release heat energy. This concept known as the standard heat of reaction helps us understand how much energy is produced when these fuels are used in power plants or industries to generate electricity. Next, we have car engines. Car engines also rely on the same principle. The fuel inside the engine burns rapidly with oxygen, releasing heat energy. This energy is then converted into mechanical motion that makes the car move. In the pharmaceutical and chemical industries, when chemists are designing a new drug or compound, they are not just creating a new molecule, they are building a structure with stored energy. The standard heat of formation tells them how much energy is stored in that molecular structure. By knowing this, they can predict the molecule stability. Finally, in large-scale industrial manufacturing, like in the cement and glass industries, by calculating the heat of reaction, engineers can design the reactor that can work efficiently. Example question and answer using MATLAB. That's all from us. Thanks for watching.